This is Quick Clip 3.06 Part 2, Balancing Act, where we talk more about balancing equations. In Part 1, we talked about how to read a chemical formula. For example, we have H2O, and this means that we have two hydrogens, H2, and then one oxygen. And then if we were to have, say, 4 molecules instead, then a large number 4 would go out in front of that formula to indicate that there are 4 molecules of H2O. And it's important that we are able to see and recognize how many atoms of hydrogen and oxygen there are in total. So for 4 H2Os, we have a total of 8 hydrogens because each molecule has 2 hydrogens, but we have 4 molecules. So that gives us a total of 8. And then each molecule has 1 oxygen, but we have 4 molecules, so we have a total of 4 oxygens. Another example here is CCl4, where we have 1 carbon and 4 chlorine atoms. And if we were to have 3 of these molecules, a 3 would go out in front, and we would have a total of 3 carbons and a total of 12 chlorines. 4 chlorines for every molecule, but we have 3 molecules, so 3 times 4 equals 12. And so in balancing equations, we should understand the conservation of mass, and that's the principle to why we have equations that need to be balanced. And what this means is that what we start with is what we end with. Conservation of mass says that nothing is created and nothing is destroyed. So what we start with is what we end with. What we have on the left is 2 nitrogens and 6 hydrogens. So that's what we start with. What we end with will also be 2 nitrogens and 6 hydrogens, but they're going to be arranged differently, and that's what happens in a chemical reactions. We start off with formations, and then the atoms break apart, and then it's reformed in different molecules. So here we have 2 NH3 molecules. But if you notice, there are still 2 nitrogens and 6 hydrogens. So that's the conservation of mass that tells us that equations should be balanced. So here's an equation that is balanced. On the left, we have 2 oxygens. We have 4 hydrogens. And then on the right, even though they are arranged differently, we still have 2 oxygens and we have 4 hydrogens. So that's a balanced equation. Here, again, we have 1 carbon, we have 4 hydrogens, and we have 8 chlorines. And then on the right, we have 1 carbon, we have 4 hydrogens, and we also have 8 chlorines. And if it's hard to recognize those 8 chlorines, take a look at this number 4. So that's Cl4. So that's saying in that molecule there are 4 chlorines. And then here we have a big number 4 in front of an HCl. So that indicates that there are 4 chlorines in total in that group of molecules. So on the right side we have a total of 8 chlorines. All right, so here's an example of an equation that is not balanced. So on the left we have 1 carbon, we have 4 hydrogens, and we have 2 oxygens. On the right we have 1 carbon, we have 4 hydrogens, and we have 4 oxygens. So looking at it, we see that the oxygens are not in balance. So on the right we have 4, on the left we have 2. So in order to balance that, we need to put a coefficient number, a big number in front of one of the formulas to turn that oxygen from A2 to A4. So we're going to put a 2 there. And so that will create, instead of oxygen being 2, oxygen is 4. So we need to start with an extra molecule of oxygen for that chemical reaction to be balanced. Here's another one. Magnesium, oxygen, creating magnesium oxide. On the left, we have 1 magnesium. We have 2 oxygen. On the right, we have 2 magnesium, and we have 2 oxygen. The oxygens are balanced, but the magnesiums are not balanced. So in order for us to balance that, we're going to try to change that magnesium that equals 1 into a 2. And the way to do that is to put a 2 in front of that magnesium, and now that 1 becomes 2. And so now we have 2 magnesiums and 2 oxygens on the left and the same on the right, and those equations are balanced.